I am Ira Dean, and this is my EE Science 2 presentation on RFID. Here are the main components of the most popular form of RFID. Passive RFID consists of the reader and the tag. The reader would be connected to a power source and a processor, which is normally a microcontroller that processes the information that is read. When the reader is on, a sinusoidal voltage signal is applied to the coil, a magnetic field is produced by the coil, and the device is ready to read a tag. The magnetic flux density is the value used to calculate the voltage induced in the tag and is equal to the magnetic field times the permeability. The magnetic flux intensity is equal to the permeability times the current over 4 pi. That quantity is multiplied by the contour integral of the cross product of the differential surface area and R over R cubed. This is the Biot-Savart's law, where R is the vector between the reader's coil and the tag's coil. We integrate the contour between 0 and 2 pi times the number of turns. As you can see on this reader, majority of the space on the board is the antenna with 50 turns. This is because the magnetic flux intensity is proportional to the number of turns. This coil will interact with the coil in the tag by inductive coupling to read the data on the tag's microchip. When a tag is close to the reader, a voltage is induced in the coil, which can be calculated with Faraday's law. The reader in the tag behaves like a transformer. The voltage in the tag is equal to the negative number of turns times the integral of the dot product of the partial derivative of the magnetic flux intensity with respect to time and the differential surface area. Once the current is flowing sufficiently through the microchip in the tag, the chip produces backscatter modulation. Backscatter modulation is how the tag communicates with the reader. The tag's chip continually shunts the tag coil with a transistor based on the information stored in the chip to be read. This process creates a modulated voltage that can be used to digitize the signal. The backscatter modulation signal is then detected by the reader's antenna and sent to the microcontroller, which is programmed to convert the signal to binary data and handle how the data will be used, whether it's opening a door, counting inventory, or anything else associated with RFID. RFID is widely used in our society to quickly track items and to securely identify things or people. RFID is commonly used to keep track of inventory accurately and efficiently in warehouses, retail stores, and libraries. The technology is used to read information quickly to verify secure information in passports and credit cards. They use a more sophisticated form of RFID called near-field communication, which are encrypted but still use the principles of electromagnetics mentioned previously. They are implanted in pets in case they are ever lost. They will be identified and returned to their owner. Even people have RFID tags implanted in them to unlock things and automate things like lights, air conditioning, or computers. There are 3 different types of RFID tags: passive, semi-passive, and active. And that concludes my presentation. Thank you.